Welcome to The Explainer. As a tech policy analyst, I've been watching what's probably the most consequential technological rivalry in modern history unfold right before our eyes: the US-China AI race. We all hear a ton of noise about artificial intelligence every single day, but to truly understand how this global race is actually playing out and why we are currently in the middle of a geopolitical Sputnik moment, we have to break it down objectively. We're going to analyze AI not as some kind of magic, but as a highly structured three-layer stack. By the end of our time today, you'll see exactly how this technological battlefield operates, from the absolute bottom up. To really grasp where we are today, we've got to look back at how this whole thing started. In 2016, a computer program called AlphaGo absolutely stunned the world, and specifically the reigning human champion, Lee Sedol, by playing this totally alien, mind-bending move known as Move 37. It wasn't just a win, it revealed a strategy that literally no human had even considered in over 2,000 years. To Chinese scientists and policymakers, this was a massive, unmistakable wake-up call. It led directly to China's 2017 national strategy to just completely dominate AI by 2030. Fast forward to 2026, and the sudden launch of the Chinese AI model DeepSeek catches the Western tech world completely off guard, creating a true, undeniable Sputnik moment. So this brings us to what we call the AI stack. AI isn't just one single piece of tech. It's multiple layers of dependent technology sitting right on top of one another. Specifically, we're looking at hardware, models, and applications. This intense rivalry between the US and China isn't just one single race. It is happening simultaneously across all three of these distinct layers. And here's the golden rule: if you don't control the layer below, you absolutely cannot build the layer above. Here is our roadmap for today. 1. The geopolitical AI wake-up. 2. Layer 1. Hardware choke points. 3. Layer 2. Software optimization. 4. The economics of training. 5. Layer 3. Multimodal data. And 6. The next AI battlefield. Starting off with Section 1, the geopolitical AI wake-up, setting the stage. Moving right along to Section 2, Layer 1, hardware choke points, the physical foundation. All right, so at the absolute bottom of the stack, we have microscopic silicon switches that are capable of flipping between 0 and 1 billions of times per second. Without this physical hardware, there is no AI. End of story. But the geopolitical reality of who actually manufactures these chips, that is the ultimate choke point. NVIDIA designs the world's most advanced AI chips, sure, but they are manufactured by just one company over in Taiwan, TSMC. Because TSMC relies heavily on American software, American patents, and American machinery, the United States leveraged that to enact strict export bans. Basically, under US law, TSMC cannot sell these highly advanced AI chips to China. This effectively locked China right out of the global supply chain for top-tier GPUs, forcing their developers to rely on a massive hardware bottleneck of older, stockpiled chips. And the crucial point here is just the sheer economic barrier we're talking about. A single top-tier NVIDIA GPU, something like the Blackwell B200, costs up to $40,000. 40 grand! And you don't just need one. To train a massive foundation model, you need tens of thousands of these things wired together in multi-billion-dollar data centers. For a while, most experts in the West just assumed this massive hardware and financial barrier meant China's AI ambitions were totally dead in the water. Up next is Section 3, Layer 2, Software Optimization, what we can call the Model Rebellion. Because extreme hardware limitations completely cut Chinese engineers off from just brute forcing their way to the top with the best chips, developers at companies like DeepSeek really had no choice but to fundamentally rewrite the rules of software engineering. They took an architecture called Mixture of Experts and pushed it to an absolute extreme. Normally, older AI models would light up their entire massive brain to answer a single question, which wastes huge amounts of power. But DeepSeek? They sliced their model up into 256 tiny, hyper-specialized experts. So if a user asks a complex coding question, an ultra-efficient router activates just 8 of those 256 experts. The vast majority of the model's brain is just left completely asleep. This drastically saves power and amazingly compensates for their much weaker hardware. But wait, they didn't stop there. DeepSeek engineered 2 other major breakthroughs. First, they invented something called multi-head latent attention, or MLA. It essentially acts like an extreme short-term memory compression tool, shrinking the AI's memory footprint by a whopping 90%. Second, they completely bypassed the standard automatic software that most AI uses. Instead, they wrote highly customized low-level PTX code. It's basically like driving those older GPUs like a manual transmission to squeeze out absolutely maximum processing speed. Finally, they made the whole model open source, allowing thousands of outside engineers to experiment and innovate in parallel. A real game changer.
Which brings us to Section 4, the economics of training, focusing on financial strategies.
So what did all those clever software tricks actually achieve? They didn't just save computing power. They completely upended the financial strategies of the entire global AI race. $6 million. That is the staggering punchline here. By combining memory compression, custom low-level coding, and older chips, DeepSeek successfully built a world-class AI reasoning engine for roughly $6 million. Let's put that into perspective side by side, because this really matters. Western companies like OpenAI spent hundreds of millions of dollars. They use a hybrid approach that relies heavily on expensive human experts to carefully label data, making absolutely sure the AI is highly controlled, safe, and polite. DeepSeek, on the other hand, purely out of financial necessity, leaned entirely into automated reinforcement learning. They literally just let the model self-correct, using a scoring system. Now, funny enough, this initially made the DeepSeek AI absolutely brilliant at math, but pretty terrible at actually talking to humans. It started doing this thing called language mixing, literally mumbling to itself in this bizarre hybrid of English and Chinese, because it only cared about the right answer, not about being polite. But ultimately, it worked. Moving up the stack to Section 5, Layer 3, Multimodal Data, the Application Ecosystem. We've reached the final consumer-facing layer here. Because look, a model, no matter how incredibly efficient it is really just an empty brain without fuel. And that fuel is data. Multimodal data is a massive collection of high-definition video, audio, and images. It effectively gives an AI eyes and ears to actually understand the physical world. And here's why this is so critical right now. Western AI companies are currently hitting a massive text data wall. They have essentially scraped all the high-quality text available on the open internet. To make an AI understand physics, like how water splashes or how a human moves, you can't just use text anymore. You absolutely need video. And this perfectly illustrates China's huge structural advantage. Enter ByteDance, the parent company of Douyin and TikTok. They operate this incredible super app pipeline, perfectly designed for multimodal data. Because they own the platform itself, they aren't scraping from the outside. They already possess uncompressed, native, high-definition video files. And this data is perfectly categorized with algorithmic metadata, exact tracking of camera angles, lighting, and even millisecond-accurate data on exactly when a human viewer lost interest and swiped away. The contrast between the two is just stark. You've got American AI companies forced to scrape compressed, fragmented data off the public internet, and they are increasingly facing severe copyright lawsuits for doing exactly that. Meanwhile, Chinese AI companies, powered by tools like Cdance 2.0, are seamlessly harvesting an infinitely growing, perfectly labeled video database directly from their own internal super apps. They have hundreds of millions of daily users constantly feeding this machine, completely behind a closed loop. It is a massive, relentless data pipeline that the West currently just cannot match. And finally, Section 6, the next AI battlefield, shifting to the physical world. All right, we've climbed from the hardware chips right up to the software models and straight into the multimodal data apps. So where does this global technological rivalry go next? Well, the source material points to a monumental shift. The future of AI requires understanding real human beings and the actual physical world, not just endlessly scraping text from websites. As digital text data finally runs out and even video data starts hitting limitations outside of its home region, the race will inevitably move toward real-world robotics and physical AI agents. The data of the future might actually come from the physical world itself. So I'll leave you with this final provocative thought. We've seen how incredibly quickly the balance of power shifted, from the AlphaGo wake-up call to the strict hardware bans to DeepSeek's $6 million software rebellion, all the way to these massive multimodal super apps. As that infinite well of digital data finally runs dry, who is going to be the first to capture the physical world? Thanks so much for joining me on this explainer today. Definitely keep this 3-layer stock in mind as we watch this incredible race continue to unfold.